Now we're going to pivot and talk about testing. Let's motivate our testing discussion a little. And check this out. So this is the Mars Rover Curiosity. It's beautiful. Now imagine you're working on the Mars rover, this particular Mars rover. Whoops. Go on to this next slide. Beautiful, beautiful. You have this task. You have this rover on Mars, and it collects a sample of dirt, of some of this Martian dirt, and it analyzes it and will send back the soil data. So just the contents of the soil. And your goal is to write a program to detect if there is life in the soil. You need to write a program that detects whether there's life in the soil. How are you going to do that? Well, Earth life, what we know, leaves behind DNA. There's protein enzymes, other signs of life, like water even maybe. So we can write a program to look for those. Okay, so if we see them, there's life. And now how are we going to test this program works? Well, once you've written your program, you can give it some rich soil that has lots of protein, enzymes, and we should expect it to return true if you've written our program correctly. So you are trying to test this program and you give it some rich soil. Is that it? Is that all you need to do? Is you just need to show that your program returns true if there are protein enzymes? Well, what about the case where there's not a ton of enzymes? Maybe just a few enzymes. Still enough where we think there's probably life on Mars, but not like just tons of them. We should try that case out too. So maybe test to try it on some soil that has just a little bit of protein enzymes, and then we're going to check to make sure that it returns true. Do you think we're done yet? Can you think of any other case that we need to check? Okay, well, the description I gave was DNA and protein enzymes, so we need to test for DNA too. We probably need to test for rich in DNA. Also, if there's just a bit of DNA, maybe it's harder to, the numbers are smaller, but we should still use that. Do you think we're finally ready? So, again, our statement was soil that is rich in DNA, that has DNA or has enzymes in it, probably is a sign of life. So we wrote a test, we checked. If we show it rich DNA, it returns true. If we show it thin DNA, it returns true. If we show it rich in enzymes, it returns true. And if we show it just a bit with enzymes, it returns true. Can you think of any other case that we might be missing? Because I can. We never actually checked the case where there's nothing in the soil and it should be no life, right? Because if we don't check for that case, you could just write code that says always return true. And the 4 cases that we've written would pass for that code. And that would be a pretty bad life detector, Martian life detector. So when you're testing your code, you only know what you've tested. Okay, so now we know, all right, we'll need one more test case. We need to see if we give soil that doesn't have any enzymes or any DNA, our soil analysis program should return false. So when we're testing our code, this is a lesson, we test if something works by giving different kinds of inputs, and we see if the outputs that are returned are what's expected. And this idea should be familiar from all of the autograder tests that you see on your assignments, for the project, for everything. When we test your code, we treat your code as a black box. And this is this term that means we can't look inside of this black box. It's opaque. We don't know what's inside. All we know is that we provide some input, and we check that the output of your code is what we expect. And that output could either be, it could either be a function that's this black box, and we call your function and we look at what's returned, or your entire program is a black box, and we give some input to the program, and then we just see if it prints the screen or if it writes to a file or something. And this is this concept of black box testing, which is you don't want to rely on the inner components of the machine. You just imagine this as a self-contained machine, and you feed something in, and you check that the thing that comes out is correct. So here's another situation where we can think about black box testing. Let's say you were a vending machine manufacturer, and you came up to the vending machine and you put in $1. You punched in A4, and out came this orange soda thing. Okay, so maybe this is row A. Probably this is row A. 0, 1. Oh, probably starts from 1. 1, 2, 3, 4. Yeah, it spits out orange. Does this test prove that the machine works? Probably not, because we don't know. What if it always spits out an orange soda, regardless of what number you put in? Even though for like, I don't know, B2, it should spit out water, and for C5, it should spit out whatever this thing at the top is, this soda can.